Hello everyone, hope you are doing good and welcome back to my channel. Today we have a very interesting question. So let's see what the question is. So this is problem of the day 4 of the January month, and let us see what the question is. So this is going to be a very nice question. It at first it may look easy, but just remember one thing: whenever such a kind of question comes in an interview, you are required to give at least two or three different ways of solving it. Okay, first one should be the brute force approach, then the advanced approach, and so on like that. Okay, so in this particular question, I will show you the exact same thing, like what approaches you can think of and what approaches you should be coding. Okay, we'll discuss all those things. So please bear with me. This is going to be a very nice video, and I'm definitely sure you will appreciate this video at last. So let's see what the video is. It's question: find element occurring once when all others are present thrice. The name of the question conveys the whole thing, but still we will see the examples. Okay, so basically we'll be given two things. First one is the array. Okay, and next thing is the length of the array. Okay, let's see what the question is now. Given an array, okay, arr of length n, every element appears thrice except for one. Okay, which appears only once. Okay, which occurs only once. Find that element which occurs once. So if you see in the example, so we can see that one is appearing thrice. Okay, but only 10 is appearing once, so we'll have to return 10 as the output. The question is very simple to understand. I don't think there is anything which you won't be able to understand in this question. So see the second example. In this case, I can see that 34 is appearing three times. Okay, that is there. I can see that one is also appearing three times. You can see that one is here and it is here in the middle and in the last also. If we talk about two, you can see that two is also appearing for three times. Okay, so there is only one thing which is appearing only once, which is three. So we have to return three as the output. So I will again repeat the question. So every element appears thrice, okay, except for one, which appears only once. That you have to return as the output. Okay, the question seems very simple. There are many ways to do it, but let us see what is the expectations here. The expectation is that you should be solving it in constant space complexity and O of n time complexity. Okay, this is where the real test comes. See, there are many ways to solve it. I will show you various ways. I will show you total three approaches. Okay, and you will have to decide which one is the best approach. Okay, but remember, whenever you get this kind of question in a interview, okay, coding interview, definitely expect that after the brute force approach you will have to solve it at least one or two more approaches in optimized way for you to get selected in that. Okay, so we'll see that now. We'll induce that whole scenario of the interview here, and let's see what we can do. So this is going to be my first approach. If you have been following my video, you should be knowing what I'm doing here. It's very simple. So, by the way, this is called the mapping or the dictionary in Python. Okay, what we're doing is we are storing the frequency of the elements. Okay, we are storing the frequency of the elements. That is, we are going through each element of the given array. I am calling each of them as I. Okay, I am checking if I is there in my frequency or not. If the first is the first time I'm seeing the I, that and I will I include a pair in that. Okay, I will do the whole tracing also. Don't worry if you have been if you are new to this video. So what we are doing is if I am coming to a key which is appearing for the first time, so I'm marking its frequency as one. Okay, if I am coming to a number which has already been there, so I'm simply increasing its frequency by one. Okay, as simple as that. But at the same time, I'm doing one more operation, which is this. If I'm after incrementing the frequency by one, if I'm getting to know that the frequency has reached three. Okay, so I am popping that whole key value pair out. Okay, I will trace and show you how it works, but for now just listen to what I'm just listen to the explanation. Okay, so this is the whole thing I'm doing. At last, what I'm doing is I'm going through the whatever keys are left in that. The very first key which I'm getting, I'm returning that as the output. Okay, that is what I'm doing. So let us quickly trace this out, and then I will quickly run this and show you. Okay, so for the first example, I will trace it out. The first one comes, what will happen? This is the first time I'm seeing the one, so I will include a key value pair. Okay, one. So this is what will be implemented. Okay, this is the code which will be executed. Okay, so one is coming for the first time. Okay, similarly, if you go to the next element 10, 10 is also, see, this is the where I'm tracing the example one, by the way. So 10 is also coming for the first time. So what will happen? I will include a key value pair. Okay, I will include a key value pair. Key will be the element and its value will be the frequency. Okay, so 10 is also appearing for the first time now. Okay, now one comes again. Okay, now remember, this is not the first time one is coming. This one has already been there. So this part of the code will be executed. What we will do, we will increment the frequency by one. Okay, this is the one, its value will be incremented by one. So it will become two now. Okay, that's it. Similarly, another one comes. What will happen now? Again, this part of the code will be executed. Okay, what will happen now? I will simply increment the frequency by one, so it will become three now. Okay, now whenever see, every time I increment, I will again check this. Okay, so in this case, after this third one, what will happen is that I will this condition will become true now. Okay, the frequency of 1 will be 3 now. Okay, as you can see, the frequency of 1 is 3 now. Okay, so what I will do, I will just pop that key value pair out. Okay, so what I will do, this whole thing will be deleted now. Okay, this whole thing will be deleted. Then I will execute this part of the code. Okay, what I'm doing, I am going through the keys. Remember, if I type here keys here, that means only the keys will be selected. Okay, and by the way, there obviously, see, whenever we do execute this part of the code, I am sure, pretty damn sure, that there will be only one key value pair left and only one key will be selected. So whichever key is selected first, I am going to return it out. Okay, so the one will be returned in this case. Okay, sorry, I am selecting the keys, so 10 will be returned in this case. Remember, 1 is the value, 10 is the key. Okay, so as you can see, the answer is coming. I will quickly run this code and show you if it works. And then by the way, this you can even segment this code, and this is efficient as well. Okay, this will be segmented, you won't get any time limit exceeded errors also. So as you can see, this is running, and you can segment it and you can check this works. Okay, it no time limit exceeded error will come here. Okay, now we'll go to, see, this is the first approach, right? This is a very simple and basic approach, anyone can code this, right? Now coming to the most interesting part. Remember, till now we have not utilized some of the facts here. Okay, remember, obviously our solution is not satisfying this. Okay, this is not satisfying this, let me admit it in the starting itself. Next thing is that we have not used these constraints as of now. Okay, if you should be in a position to use these constraints as well, only then you will be able to code it in this way. Okay, so what are the constraints? Remember this, a of I can be from 10 power 9 positive to 10 power 9 negative. Okay, this fact we have not utilized till now, and next, in the next solution, I will be utilizing that. So by the way, this is going to be a Java code, and I will show you the same code in Python as well. But why I'm showing Java code, we'll get to know in some time. But just for now, just bear with me. So coming to the fact that, by the way, in a Java or in C++, what happens is that a integer is basically allotted 32 bits. Okay, that is 4 bytes, and each byte is having 8 bits. So 4 into 8, which is 32 bits. So can you quickly Google and tell me what is the biggest unsigned number that can be stored in 32 bits? uh, if you don't want to do that, I have already collected the results. This is the number. Okay, so if you do some quick observation, you will get to know that these are 9 digits here after 4. That means this number is approximately equal to 4 into 10 power 9. Okay, this basically is greater than 4 into 10 power 9, but just for approximation I'm telling you. Okay, so this number is going to be 4 into 10 power 9. That means in a 32 bit I can store in an unsigned way 4 into 10 power 9 values. Okay, that is the biggest number that we can store. So what is our constraint, by the way? Our constraint states that we don't need 4 into 10 power 9, we just need 10 power 9. Okay, 10 power 9 positive, and at the same time 10 power 9 negative. Okay, so that's what we need. Okay, so can you quickly tell me, if I can store in a unsigned way 4 into 10 power 9, can I store 10 power minus, that is minus 10 power 9, till positive 10 power 9? Obviously we can do that. Okay, that means one thing is very clear: 32 bits are enough to store from minus 10 power 9 to positive 10 power 9. Okay, if you this discussion is important. Okay, the interview will give you this hint. Definitely believe me, if this question comes in interview, after you code the first solution or any brute force solution, definitely the interview will ask you, can you please quickly tell me what is the maximum number that you can store 32 bit? Then you will have to derive that number, and then you will have to understand that the given that is the given thing. Okay, this thing can be done in a 10 power, that is 32 bits. Okay, this can be accommodated in 32 bits. If that is so, let us see the solution now. Okay, so what, uh, see, the only thing why I'm showing the solution is that I want to achieve this. Okay, I want to achieve a space complexity of O of 1. Okay, for that I am doing the solution. For that you will have to use this fact. Okay, as simple as that. The idea here is, I am sure that 32 bits are enough to store this all possibilities of a of I. Okay, array of I. So now what I'm doing is, see, try to understand this approach. I will go bit by bit now. Okay, so that is every see here, every element of this ARR can be accommodated in 32 bits. Okay, so what I'm going to do is, I am going to do a bit by bit approach. Okay, so what I will do is, for, let us say, this array has 10 elements, so I will go go to the 0th bit of all the 10 elements, and then I will see which of them are 1. Okay, which of them are 1. Let me say that let us say that some x number of bits are 1 out of 10. Then I will do it, modulo by 3. Why modulo by 3, by the way? See, try to understand this fact. If numbers are repeated, as you can see here, 1 is getting repeated, right? See, if a number is repeated, then obviously their bits will also repeat. Okay, their bits will also repeat. For example, in this case, if I talk about the 0th bit, okay, the 0th bit, for these three, the zeroth bit will be 1. Okay, that's why this is the basic idea which I'm going to use. Okay, so if the number is same, obviously their binary representation is also going to be same. That means obviously if I take any bit, let us say 8th bit or 9th bit, they are also going to be same for same numbers. Okay, that's what the idea is. That's why if I do a modulo by 3, so modulo by 3 will ensure that, if see modulo means it will give me the reminder, right? The idea here is if a number has 1 and it is repeated 3 times, that means if I do a modulo, the answer will become 0, right? That is, our answer will not be affected by that. But if a number is present only once and it has, let us say, x, the 0th bit is 1, in that way, yeah, 1 will then contribute for the answer. The idea here is we will eliminate all those bits which are not contributing for the answer. But yeah, the bits which are going to contribute, that is the numbers which are going to contribute for the answer, only the bits of those will be retained. Please again understand what we are doing here. The numbers, by the way, the bits of the numbers who are not going to contribute for the answer will be eliminated, and the bits of the number which is going to contribute for the answer will be retained. That is what we are going to do now. Okay, I will quickly explain the solution, then we'll try to understand the testing part. Okay, so we are having two for loops here. For the first for loop is going to be from 0 to 31. Okay, 0 to 31 is also basically 32 bits only. Okay, that's what it is. For each loop we are having a sum variable. Okay, in the sum variable we will store, see, idea here is we'll go through each number of the array and we will go through their ith bit. Okay, I will start from 0, we'll go through the ith bit of each of those numbers. How many of them are 1, that will be stored in the sum. So sum is basically the count of bits having 1 in the 0th place. Okay, that's what it is. So just understand this, sum will store the number of bits which are 1. Okay, that's what it is. So we are going through each element. See, this is the second for loop now. In this for loop, what we are doing, we are going through each element. Okay, we are doing something like this here. What it means, I will explain you. But the idea here is, see, we are right shifting number by I. Okay, right shifting number by I, then we are doing and by 1. Okay, what is the meaning of this? See, whenever we do right shift by a number by I, what it means is, let us say I'm doing a right shift by 2. That means, okay, I will just quickly do this and show you. See here, for example, if you talk about the number, let's say 1101. Okay, so what this number is, by the way, this is 8 plus 4, which is 12, and then plus 1. Okay, it is 13, by the way. So in decimal, this is going to be 13. Okay, this number is going to be 13. Okay, 8 plus 4, which is 12, and then plus 1, which is 13. Now if I do a right shift by 1, okay, just see this. See, if I do a right shift 1101, if I do a right shift by 0, what will happen? Okay, nothing will happen, right? This number will remain as it is only. Okay, this number will remain as it is, 1101. Okay, then if I do AND by 1, what will happen? Only the first bit will be retained. Okay, if I do AND with 1, okay, uh, yeah, and with 1, what will happen? Only the first bit will be retained. First bit is 1, so it will remain 1. Okay, now let's talk about the second case. Okay, I have 1101, right? If I do a right shift by 2, let us say, okay, for just for understanding, um, okay, let us do by 1 only. Okay, I'm doing a right shift by 1. So what will be the number now? See, the number will right shift by 1. Okay, so what it will become? See, 110 will be remained and an additional 0 will be obtained. Okay, see, this part of the code is retained here. Okay, and additional 0 came in the left. Okay, that's what it is. This is the result of right shift by 1. If I do a AND with 1 now, okay, if I do a AND with 1, what will happen now? See, the first bit will be retained. Okay, so it will be 0. So I think by now you would have understood what we are doing here. I am going to retain the ith bit. That is the basic idea of what I am doing here. Okay, this operation retains the ith bit. Okay, if the bit is 0, the answer of this will be 0. If the bit is going to be 1, the answer of this is going to be 1. Okay, just me, yeah, retaining the ith bit. Okay, ith bit value. Okay, that is going to be either one of this. Okay, 0 or 1. If the ith bit of the num is going to be 0, it will be the answer of this will be 0. Okay, if the ith bit of the num is 1, the answer of this will be 1. Okay, and then I'm counting it. Okay, so basically, see, if 0 is there, obviously nothing is adding in the count, right? So basically sum is going to count the number of ones in the ith bit of all the numbers in the array. Okay, so basically this is going to count number of 1. Okay, basically the idea is number of in the way, see, try to understand what we're doing here. For the ith bit of the numbers which are having 1, okay, that is the count, of elements of array having 1 in ith bit. This is what we're doing here, okay? In the count of elements of array having 1 in the ith bit, okay? This is what we're doing here, okay? See, once we have the ith bit, that is the count here. Once we have the sum, that is, once we come out of this loop, we'll have that. Okay. Now we'll do a modulo by 3. Why we are doing modulo by 3? The answer I've already explained to see. If the numbers are repeating, see, for example, let us say a number is present 3 times. Okay. So obviously their ith bit will also repeat. Okay. It will also be there. So if it is 0, no problem, avoid it. But if it is 1, then we will have, the number of ones will be, multiple of 3. Okay. So that's why we are doing a modulo by 3. But remember, this particular number which is only present once may also have a 1 in that ith bit. Okay, so that idea here is, once you do a modulo by 3, that's why I mentioned either it will be 0 or 1. Okay, if it is 0, that means our answer does not have a 1 in the ith bit. If it is 1, that means that is the number which is present only once, that is the 10 in this case. Okay, has a 1 in the ith bit. That is the idea. Okay, this one basically means that the answer which is, the number which is present only once is also having a 1 in the ith bit. Okay, this is what we're doing. And then basically we are, adding it to the answer. Okay, and then I'm again left shifting it by 1 I, because we have right shifted, right? I'm again going to left shift by I, and then I'm going to add it. Remember, once I left shift by I, the idea here is it will gain its position. Okay, for example, and try to see this thing. For example, if you have 0, 0, 1, okay, and if you're left shifting by 2, okay, what it will become, by the way, it will become 1, 0, 0. Okay, and what is the value of this? What is the value of 100 in decimal? The idea here is it is 4. Okay, it is 4 in decimal. Okay, so that means when you left shift, the position value also increases. Okay, it basically multiplies by 2. For example, if you left shift by 2, see, this number is 1, right? 1, and you left shift by 2, so it will be multiplied, by 2 by 2. Okay, that is 2 into 2, which is 4. Okay, that is the basic idea. So I am again making its gain its position value, and then I'm adding it to the answer, and then finally we return the answer. Why this solution works? See, one thing is that, see, the question which you will get is that, see, what about negative numbers? I hope you know the concept of two's complement and all those things. See, when it comes to negative number, the 31st bit, okay, the 31st bit will be a signed bit. Okay, the 31st will be a signed bit. We are also including 31st bit in our calculation. That means if the answer is having negative, that is, if suppose it is minus 10, okay, then the 31st bit of it will also be having a 1, and that will be contributed to the answer. So this particular answer will also be having the 31st bit as 1. So it will be, interpreted as a negative number. That's what it is. That's why the solution works. Now if you do the exact same code, see, that's why I wanted to show this in Java, by the way. If you code it in the exact same way in Python, this solution will not work for negative numbers. Why that is so? See, in Java and C++, there is a concept of, integer, right? Integer has, 32 bits, but in Python there is no concept of 32 bits there. Okay, see, first of all, there is no, we are not defining an integer or, string like that, right? Don't give data types in Python. That's why this solution, if you code as it is in Python, this will not work. Okay, so how to code in Python, I will show you now. See, this is the way I am doing it. Instead of, see, here we are simply adding it to the answer, right? In Python we cannot do like that, because, if you do that, see, the 31st bit, if it is 1, it will be interpreted as a negative number only in Java and C++. The same will not happen in, Python. So the idea here is, instead of, taking it as an integer, I am going to take it as a string. Okay, this is the, see, the same exact same code is there, but we will have to introduce some more variables. Now I'm including a variable called negative. See, this solution is in Python, by the way. The previous solution which I showed you is in, Java. Okay, what I'm doing now, see, try to understand the exact same solution I'm trying to implement in Python. If you do the same way, it will not work, but you have to make some changes. I am showing you what changes you should make. Okay, so see, this I am taking as a string now. Okay, this is no more a integer. Okay, then I'm declaring flag called negative. Okay, so everything remains the same. I'm doing sum is equal to sum percentage 3. Everything is same, but only one difference will come. Instead of, see, here I went from 0 to 31. Okay, I started from 0 to 31. In this case, I will start from 31 to 0. Okay, why I'm doing that? Because the 31st bit will tell me whether the number is going to be negative or positive. That's why I am checking if I is equal to 31 and sum is equal to 1. That means this number is going to be negative. So I'm I'm making the boolean value negative as true. Okay, initially it will be false. So once I make the boolean value true, what will happen now? See, for all, see this will happen only for the first bit, right? After the, what will happen every time, see, once I get to know that this is negative, every time this code will be executed. Then for every other, bit, what will happen now? See, if negative is true for every bit, see, if sum is 0, that is see, we are doing the sum, yeah, this thing. If it is 0, I will add 1 to the answer. If it is 1, I will add 0 to the answer. Why I am doing that? Remember, this concept is about 2's complement. So see, if you have a number, let us say 8, you have a 2's complement of it. Okay. If you want to know the 2's complement of -8, what you should do? Take the 2's complement of 8, positive 8, you know, and add 1 to it. As simple as that. You have to do a binary addition. That's what I'm going to do. Okay. So yeah, this is as simple as that. If this is not the case, if the answer is not true, you can simply add the string as it is to the answer. So, see, this answer is about negative complement. See, try to understand what we're doing here. If you have a number, let's say 8, okay? So, what is 8, by the way? Let me quickly do this and show you. 8 is going to be, let me not take 8, let us take 6, okay? What is 6 going to be? It is 4 plus 2, right? So, 0, 1, 1, 0, okay? It is 4 plus 2, 6. So, what is going to be -6 now? How to find -6? See, there are two ways to do it. The first way is, see, whatever is the value of 6, right? Whatever is the value of 6, reverse every digit. So what you will do, it will be 1 0 0 1. Okay, I have simply reversed every digit. Okay, I have reversed every digit. See, once you have that, you have to do a binary addition with 1. Okay, binary add with 1. If you add a 1 to this, what will happen now? What this number will become? This will become something like this. Okay, 1 0 1 0. Okay, this is what it is. And yeah, this is the way how it should be represented in -6. Okay, this is the way how it should be represented. Okay, so yeah, this is the binary representation of -6, by the way. Okay, so as you can see, what we're doing, we are simply reversing the digits, and we are doing addition with 1. Okay, this the exact thing I will do. So I am here, if the answer is 0, the sum is 0, I am incrementing 1, and if it is 1, I'm adding 0. Okay, at last, once we come out of this follow, what I will do now, see, this is the what thing I will do now. Okay, see, I will do I will convert it integer of answer with 2, that is, I have this in string, right? I have this in string, so convert it to an integer, taking this the string as the binary representation, and add 1 to it. Why I am adding 1? Because as I mentioned, binary addition with 1. Okay, I will add 1 to it. Okay, and then obviously I have to return it by multiplying it with -1 if it is negative. If it is not negative, what I should do? Simply return the integer of it. Remember, what is this 2, by the way? This 2 indicates that the answer, which is a string, is the binary representation. Binary means 2, right? So I'm keeping this as a 2. So as you can see, this solution, if uh, if all the numbers are negative, still the solution gives the correct answer. This is what I wanted to show you. So don't worry if you don't understand this. I will give you this code in the comments. You can just go through it. But I just wanted to show that this is the code in Java. If you wanted to implement the same code in Python, you will not get. And what you have to do, this is what I've shown you. Okay. So in today's video, I have discussed 3 solutions. The first solution was a simple one. In the second solution, we discussed why it will work, because in Java and C++, the 31st bit, okay, of every integer is treated as the sign bit. Okay, that's why it works. But the same solution, if you code in Python, it will not work. Why it will not work, I have explained, because in Python is no concept of sign bit. In there is no concept of 32 bits, by the way, for integer. Okay, because we don't give any data types, right? So this is what it is. And I have already mentioned you what is binary, that is 2's complement representation, and what is the 2 complement, how to find that 2 complement the representation for a negative number. Okay, I've done everything. Remember, see, if you go through my code, okay, please write it down somewhere, or store it somewhere. These things will help you a lot in review. Okay, in see what I'm doing here, why I am doing this. See, I am leaving these things for you to understand. Okay, I'm just giving some explanation, and I'm giving the code. It is for you to dig in what is actually happening here. Okay, because see, if I start explaining everything, the video will become very very large. Okay, so I am expecting that you will do some homework, and you will try to understand why I am doing this. Okay, I already explained that I am doing a binary addition with 1. That's why at last I'm adding it with 1. And yeah, this part is as it is. Okay, this part is as it is, and ultimately, because it's a negative number, so you have to multiply it with -1. So yeah, friend, that was all for today. This was a slightly longer video, but I hope you would have learned a lot. Because see, this question I have myself experienced this kind of, see, not the same question, but yeah, this similar kind of question in interview. Definitely believe me, simply coding one solution will not help you. They will give you these kind of hints. Okay, they will tell you these kind of hints. Okay, that in a 30 bit, what is the maximum number can be stored? Can we have this range? accommodated in 30-bit, and they will expect you this kind of solutions. So believe me, this will happen. If you are simply happy by coding this kind of solution, it will not work. That's what I wanted to show you. So I hope you would have enjoyed my solution. I know this video is slightly longer and there are some parts here which you might not have understood, but I'm hoping that you will do some homework. You definitely Google search, you will definitely get the answers. Okay. So yeah, friend, that was all for today. See you tomorrow. And yeah, thanks a lot.